In this video, we're going to look at an example using the alternating series test. So we're being asked to determine whether the series from 1 to infinity of negative 1 to the n times n over the square root of n cubed plus 2 converges or diverges. So certainly the negative 1 to the n part is alternating, and since we're plugging in n's from 1 to infinity, the n over square root of n cubed plus 2 is always positive. So we've got an alternating series here, so the alternating series test applies. So we want to determine if the non-alternating part, this part that I'm calling b sub n here, decreases and has a limit equal to 0. And when we say decreases, we really just mean eventually decreases. The alternating series test is typically saying it needs to decrease from 1 to infinity, but as long as it starts somewhere and from then on decreases, we're good as far as the decreasing part goes for the alternating series test. To show that b sub n decreases here, it's probably easiest to take the derivative, treat it as a function of a real variable, take the derivative, and see that the derivative is eventually negative. So to that end, we'll let f of x equal x over x cubed plus 2 to the 1/2. Take the derivative using the quotient rule here, do some simplifying, and we get to the point where the derivative should be 4 minus x cubed over 2 times x cubed plus 2 to the 3/2. Certainly here, since we're only considering positive x values, and in particular x values that are 1 or bigger, because that's what our n values are, the denominator is always positive. The numerator will be 0 when x is cube root of 4. Cube root of 4 is between 1 and 2. So certainly once x gets to 2, the numerator will be negative and stay negative for any x that's 2 on, which means our b sub n will be decreasing from at least 2 on. Okay, so we can conclude here that our b sub n is eventually decreasing, which we needed for part of being able to use the alternating series test. The other part we need is that the limit really is 0. So looking at our limit as n goes to infinity, we notice that the top is n, the bottom is going to behave like n to the 3/2. So we'll divide top and bottom by n to the 3/2. Simplifying the top, you get 1 over n to the 1/2. Pulling n cubed under the radical here, we get n cubed over n cubed will give us 1, and then we get a 2 over n cubed here. And then as n goes to infinity, the top goes to 0, the bottom goes to 1, so we get 0 here. You could have also used L'Hopital's rule, I suppose, but you would have had a chain rule here that would have had another, well, you would have had a chain rule here that would have had another n squared that popped out when you took the chain rule. And you would have gotten to the same point. It's just probably a little bit easier here just to divide by n to the 3/2. Anyway, going through this now, the sequence was decreasing. The sequence has a limit that's equal to 0. So our original alternating series then must converge by the alternating series test.